Hello everyone, I'm Mr. Brain and I welcome you to my channel. Today we will talk about the equation of the straight line and its representation on the Cartesian plane. We will study the equation of a vertical line, a horizontal line, and a generic line. Let's start with the equation of the vertical line, which is x equals k, where k is a constant, a real number. For example, the equation x equals 1 represents the vertical line passing through point 1 on the x-axis. This is because all points on the vertical line have x equals 1. Similarly, the equation x equals 2 represents the vertical line passing through point 2 on the x-axis. This is because all points on the vertical line have abscissa 2. Equivalently, we can say that the equation of the horizontal line is y equals k, where k is a constant, a real number. This is because all points on the horizontal line have the same ordinate. Therefore, the line of equation y equals 1 is a horizontal line passing through point 1 on the y-axis. All points on this line have ordinate equal to 1. Likewise, the line y equals 2 is a horizontal line passing through point 2 on the y-axis. All points on this line have y equals 2. To express the generic line, we need two parameters, m and c. M is the slope or angular coefficient. The value of m indicates the slope of the straight line with respect to the positive x-axis. C is the y-intercept. For example, the line of equation y equals x plus 1 is a line passing through point 1 on the y-axis and inclined at 45 degrees with respect to the positive x-axis. Similarly, the line y equals x plus 2 is a line that passes through point 2 on the y-axis and is inclined by 45 degrees with respect to the positive x-axis. Let's try to understand how the inclination of the line changes as m varies. For example, when m is greater than 0, the line is increasing because as the values of x increase, the values of y also increase. When m is less than 0, the straight line is decreasing because as the x values increase, the y values decrease. When m is equal to 0, the equation of the line becomes y equals c, so the line is horizontal and passes through point C on the y-axis. So let's pay attention that when m is equal to 0, the line is horizontal. Let's now see what happens when c varies. When c is greater than 0, the line intersects the y-axis at a point above the origin of the axis. When c is less than 0, the line meets the y-axis at a point below the origin of the axis. On the other hand, c is the point of intersection of the straight line with the y-axis. So if c is positive, the intersection point is on the positive semi-axis, above the origin of the axis. If c is negative, it is on the negative semi-axis, below the origin of the axis. Instead, when c is equal to 0, the line passes through the origin of the axis. Now we will see how to draw a line knowing its equation. Consider the equation y equals negative 1 over 2 times x plus 2. To draw the line, we need to know 2 points of the line, so we complete a table in which once x equals 0 and once y equals 0, and we need to find the missing coordinate. Let's substitute 0 for x in the equation of the line. 1 over 2 multiplied by 0 equals 0. We found that when x equals 0, y equals 2. We have thus found the first point with coordinates 0, 2. Now let's substitute y equals 0 into the equation of the line. We bring minus 1 over 2 times x on the left-hand side of the equation. We multiply both sides of the equation by 2. Simplifying, we obtain that x is equal to 4. So when y is equal to 0, x is equal to 4. We have thus found the second point of the coordinate line 4, 0. Let's call A the first point with coordinates 0, 2, and B the second point with coordinates 4, 0. Point A is the y-intercept. Point B is the x-intercept. After drawing these points on the Cartesian plane, we join them with a straight line. The straight line passing through points A and B is the line of the equation y equals -1 over 2 times x plus 2. We have achieved the aim of explaining how to write the equation of a straight line and how it is represented on the Cartesian plane. Thank you for your attention, and if you liked the video, please subscribe to the channel. And don't forget, Mr. Brain solves problems.